Okay, so 3 times 2 is 6, so 0. 3 times 4 is 12, so 0. And 3 times 15 is... Okay, so we found the pattern, guys.
Yeah.
0, 2, 4, 0, 2, 4, and 0, 3, 0, 3, 0, 3. 0.
We'd come up with something else, so then when you start to do
Oh,
it.
done.
Guys, I'm gonna just ask
Wait.
locally for us to refocus. I know that number 8 is a challenging problem. That doesn't mean we should stop trying and just start talking about other things. That means we should really buckle down and try to consciously think about this. For those of you that are on Part B right now, the conversation I'm having with these guys over here is they've sort of recognized that they're trying to find a number that reduces to 1 now rather than reducing to 0. So my suggestion was, since you guys did such a great job of getting things to reduce to 0, think about what would reduce to 0, and then logically, how do you go from that to then having it reduce to 1? Because those are interconnected ideas also.
But this is
So if you're having trouble going directly to 0, try going directly to 1. Try going to 0 first, and then backtracking to a number that would make it 1 instead.
But it's the whole dividing by 3 thing, which is...
I heard right as I started talking, I heard you say, I got it.
So like, you have 8 and then minus 7, that's 1. But if you add 7 to 8, like you get 15, 22, and stuff like that. If you subtract 7, it always equals 1. So like, 8 plus 7 is 15. 15 minus 7 is 1.
So if you started with your initial idea of 8, and then you knew each multiple of 7 beyond that.
But then I just don't get where the 3 comes
So
from.
Daryl just listed off several numbers. Write those numbers down. 8,
Yeah, 8, 15,
15,
22, 29,
29.
36.
Those are all, you're just adding 7 to 8.
Well,
So
7
you-
to...
The number.
Okay, but then those give you 1. I just don't get the next one.
Well, if it's...
Oh, so you keep subtracting 7, and then when you get to 8, you subtract another 7, and it gets you 1.
So what Daryl just did for you is he came up with all of the numbers in Z sub 7 that do what? Give you to 1. But that wasn't entirely what the question was asking. The question was asking you to...
Multiply, and one of the numbers that multiply by 3 gets you.
Right, so now you have a list of numbers to choose from.
So do you do those numbers divided by 3,
It's going to be 15.
which is 5?
5.
So is that.
So it equals
So 5 is the multiplicative inverse for 1.
So now that that's your idea, test it, see if it works. Do the multiplication, do the reduction.
It does work. Because, like, you got the 5, right? So then you do times 5, and you subtract 7, and it gets you to 8. You subtract another
And it
7.
gets you
and it
1.
gets
Yeah,
you
I get that part.
Yeah.
So
then-
find a number that you can multiply by 3.
Sounds like there was no question.
So then
So this number is the multiplicative inverse of 3
So
in
5.
this case.
Yeah.
Oh. So we don't want 0, we want 1, 2, 3, 4, 5, 6. So 3's multiplicative inverse is 5. So going with that, does that mean 4 is multiplicative? So, oh wait, so we have these numbers, and we just see which ones we can get by 4. So like 8 divided by 4, that gets us 2. So 4 is multiplicative inverse of 2. Yeah.
Is it?
Yeah, because it's a number that you have to multiply by 4. And so if you do,
And then subtract the 7.
so if you do 2 times 4 equals 8 minus 7 equals 1. So it's going to be 2. So then 5, so a number that, so we have to do one of these.
Wouldn't 5 be 3 then?
15 divided by 5.
3 is 5. 5
Yeah.
is 3.
So then 2 would be 4, and then 1 would be 8. 6 would be
36 divided by 6, 6. Yeah, I think 6. Or wait, it's 29 divided by 6.
Try multiplying.
Yeah, so 6 is multiple.
What would you have to multiply by 3 to get the answer?
So 1 is 8, 2 is 4, 3 is 5, 4 is 2, 5 is 3, 6 is 6.